Okay, so to start things off, now this is the stream power thing. So you've got this stream that flows downward, and you siphon off a little bit of water through here, goes all the way through here, ends in this box, and then drains back. So you're just taking a little bit of extra water from the stream, going through all these chambers, which then can be used to create power. And then the water eventually diverts back to the stream, and in doing so it has created power. So start with this stream, water's coming down, and there's a box underneath. Extra water comes through here and fills this box. So you've got this large red box that just is a chamber that fills with water up until a point, and it flows down through this pipe and into this one. There is a ball valve here, which can either be open or closed. When it's open, the water will flow down and into chamber 1, and linking chamber 1 to chamber 2 is another pipe and another ball valve, which can open and close. When it's closed, then no water can get in, and you have another ball valve that then will divert back to here. So to start things off, there's going to be water in chamber 2 and no water in chamber 1. Now the ball valve is flipped, so now this ball valve is open. This ball valve is open, this ball valve is closed, this ball valve is open. So because this one is open, water drains from upper chamber through here into this chamber. Meanwhile, this ball valve is closed, so no water can get into chamber 2. And this ball valve is open, so water will drain out of chamber 2. And now as that happens, so as water will flow into chamber 1, we've got this floating thing here, which has a rod connected to it, connected to another rod, connected to a, I don't know, a seesaw thing. Now seesaw thing here and here, both connected, so water's draining out here, so this floaty thing no longer has buoyancy, so it's going down. Water's coming in here, so this floaty thing does have buoyancy, so it's going up. As that happens, the seesaw thing gets pushed up by the buoyancy here. And as that happens, just demonstrate it one more time. Okay, so you can tell by these which ones are open and closed. This one's open, closed, open. Now as this one gets to the top and gets completely full of water, this triggers. And now this one is closed, so no water can get into it. This one's open, and this one is closed. So now that that happens, there's water up until this point and no water in here. Now water is draining through here, and no water can get through here. Ball valve open here. Ball valve. What the hell happened to here? Huh. Okay, I guess I'm going back now. I thought I had a rigid joint on there. Apparently not. Alright, that's on me. Okay, fine. That's on me, fine, rigid. Fine, there we go. And now they're connected. Don't know how they got disconnected, whatever. Okay. Just taking these off. Okay, so you've got this one open, this one closed, this one open, so water pushes into here. Water can't get into this one, but water's already into it. This ball valve's open, so now it's draining out. So as this happens, this one's filling with water, this becomes buoyant, this one's losing buoyancy, so this one's going down, this one's going up. As that happens, this now goes up, and when it reaches a certain point, it triggers this, which has a gear through it, which translates to here, which then has two more gears, sort of a hybrid rack and pinion thing. So then these two gears translate down to the ball valves. So as water is filling this up, this goes, and as you can see, this one's open, closed, open, but as this reaches the top, now they flip. Now this one's closed, this one's open, this one's closed. So now water will come out of here and into chamber 2. This one's closed, so water can't escape, so it just stays in chamber 2. So now we've got the water difference. So now this one's going up, and this one's going down. Now again, watch this. Once this one pushes this far enough down, the springs will push this up, which then translates through here and then down through here. And now all the valves change again. Open, closed, open, and the cycle repeats. So now water comes in here, water flows out of here, this goes up, comes to a certain point, orientations change. Yeah, sometimes these get disconnected because I did motion, or I did, not motion link, I did contact sets, which is less reliable, but it's easier for this. So then these just keep changing, and then this one's linked to this one, so they're all mechanically linked, and it works. And as this is happening, as water is going in through here, in this one and out this one, as water fills this chamber, the air that was in this chamber then gets pushed under pressure and out through this pipe. Meanwhile, this one has the water draining from it, which means that now air needs to flow into here to make up for it because it's a vacuum. So air is getting sucked into this one and pushed out of this one, and then you can just link these and create some sort of power. And then it just goes back and forth over and over again, with air getting pushed through here and sucked through here, and then pushed through here and sucked through here, and you can have something in between, like the other thing that I made, or some sort of a piston type thing, an air engine, whatever you want. And also, you don't have to end here and divert it back. You could technically just have these chambers just all the way down. If you have a stream at like a 5% grade, and instead of linking it like every, what would this be, like 40 feet maybe go 100 feet, which would let you add more, so then it would be even, odd, and you would have more ball valves, so all the evens would be on at the same time, all the odds would be on at the same time, vice versa. And from there you create some sort of a power through just the air pressure. And again, if you add more of these, then you have more water coming in, water going out. Thereby, you can harness the air. You could also do something with the buoyancy, like have 3, 6, 9, 12 ping pong balls. I think is about 3/4 of a pound worth of buoyancy. You could also harness that, so the buoyancy goes up and down. You could add some sort of a gear type thing, create power that way. I personally like more using it as an air engine, but you could do either one. So that's roughly it. Probably more to it, but that's going to be it for now, I think. Oh, this one got fucked up. Oh, and yeah, instead of doing this whole stupid thing, you could just add limit switches, which would be way easier. You just have some sort of a buoyancy here, going through here, limit switch here, same here, limit switch here, then electronics, and then probably like a solenoid valve, like a sprinkler valve. And then so when this one fills with water all the way, the buoyancy hits a limit switch, which then tells the circuit to turn on uh, what is it, valve 1, 3, 5, etc., and turn off 2, 4, 6, etc. And then when they drain to the next one, it hits that limit switch, and then it just switches. It'd be easier than doing all this, but surprisingly enough, I got enough friction removed from this whereby it's not too much of a drain on the system. I can power everything through these springs, just with the springs being yeah, with the springs being compressed, and then when they get past the 50% mark, then they release all of that, which then pushes this up, turns that, turns those, and turns the ball valves, and yeah, it should work. And that's roughly where I'm at. So I think that's about it.